Good afternoon, everyone, or good morning, depending upon where you're calling in from. As Gavin said, my name is James Graham, and today I'm co-presenting with Jason Seeley, who represents Cyclomedia. So thank you again for the invitation to present today. And so this is, I know we're all concerned with right-of-way and about how each one of our asset perspectives interact with the right-of-way. And this one's going to be obviously focused on signs. And just a little bit about me. I'm coming to you from a pure GIS background. I'm traditionally transportation GIS, but also most recently planning and historical geography perspective. So it doesn't seem like a natural fit for me to be talking to you about signs and GIS and how to manage this asset, but here we are. You know, that's just kind of where GIS leads you. Sometimes you don't expect it. But I have to say, what really has kind of drawn me here and what's keeping me here is just the amazing complexity of the asset that is the sign. So we've all seen a street like this, and this is one of the images in DC near Irving Street. And in this particular image that we have 3 sign supports, and on which there are a number of signs with a lot of potentially really complicated information. And so we could have a speed limit sign coming a little bit up street. We could have a street name sign that represents roadway information. We could also have another one that changes directionality of the street network. Parking could be prohibitive or permissive, depending upon where the arrows are pointing and what type of sign it is. Additionally, depending upon the type of sign and the day and the time, it could be a street sweeping type sign. But really just there's a lot of complex stuff out there, and you don't really have to be in a city to have all this complex information in play at just a normal street that just happens to be right near you. And part of the issue is that there's a lot of players in the game, and I'm showing just a few of them here. There's probably some small bubbles, but starting with the top, we have and IT has to support the middle bubble, which is essentially our asset management team here, that it's actually in charge of physically changing out signage. But making requests of the sign shop there's a lot of people in the mix. We could have our safety team who's in charge of making sure speed limits are dialed in and accurate. Planning is really in charge of pedestrian, other things related to bicycling throughout our city. We have a whole parking and curbside management team that is responsible for whether or not you can or cannot park there. And then permitting comes in and says, we have the right to implement a short-term exception to any of those things that you guys are putting out there and signing them. But the big bubble over there on the left is the one that generally ends up holding the bag, for lack of a better term. If any one of those actors on the right misses a step or doesn't quite deliver the right information, there's a really good chance that the public is going to be affected negatively because of it. And as you can imagine, this has happened. We've made the news in not a very particularly good light. Thankfully, these are kind of a little bit in the past, but these issues we still get tweets more nowadays. But we hit the news, and a lot of times it's not in very good ways because of sometimes we miss something along the asset management chain of connections. And then as a GIS person, again, I had to give you my background. I'm thinking, what we need is an inventory. In my very naive way, that's going to fix it all. Let's just map out the signs. And everybody was really with us. I think that just getting an inventory would help. But if you think about the signs, looking at a map like this straight up and down, even if you have an aerial turned on, you're not going to be able to see the information on those signs because you have an orthographic view of the map of the world. So what the context that you need in order to really manage and view and understand this asset is actually street level image that is connected with your GIS in a meaningful way. And we're very fortunate to have a nice ongoing relationship with our partners in Cyclomedia, and that's exactly what they do. And so they collected some street level imagery, and then also at the same time collected a very, very detailed GIS inventory of those signs. And without further ado, I'm going to go ahead and pass it to my partner, Jason.
Thank you so much, James. I appreciate that introduction, and so happy to be a, well, not only a partner with DDOT, but also a proud sponsor of this right-of-way asset mapping exchange. Just a little bit, you know, the obligatory background sign for those of you that have never heard of Cyclomedia. We are an industry leader in authoritative, high-definition street-level imagery, just as James kind of outlaid there. And when you think about, you know, evolution, or as Gavin even said, starting with clipboard and wheel, if you back up a step and think about the geospatial imagery databases, right, or databases of record that we have used over the years, right? And I've been a part of this industry for 15 years. Originally, it was orthogonal. Then obliques came along, right? And they were the nice to have, not the must have. Now they're a must have, right? And now we're also filling in that void for modern, you know, cities in need here with a street level imagery component, right? To round that out, to allow our valued customers to be able to do even more from the comfort of their desks. And while, you know, the district is obviously a major metro, to say the least, I also like to point out on this slide, you know, the Collierville, Tennessee's and Mason City, Iowa's, you know, populations of 50,000 and 27,000 respectively, just letting everybody know that we do scale. So if we move on to, you know, a lot of folks ask us, you know, how we do what we do. Well, it all starts with working with our customers like DDOT and identifying an area of interest and where we're going to capture imagery, right? So this is a shot of one of our capture vehicles, and our on-demand service allows us to capture exactly the portion of that public right-of-way that a customer is interested in, right? So you can kind of have it your way. And another question that's commonly come up to us, we drive at speed. So when we're capturing this data, that allows for a high level of safety as well as efficiency. So once we're doing that, now we move to visualization, right? So again, our world-class imagery is one thing, but we're also capturing LiDAR point clouds as well. So all of this data is wrapped into our solution and provided to our customers, and they're able to access it through our Street Smart software as a service, right? So there's an enterprise license that not only DDOT enjoys, but all the other agencies within the District of Columbia. And that allows them to leverage this data via existing software, right? And investments that they've already made. So you've got imagery, right? You've got LiDAR, right? A really super rich data set here. And now we have data insights. Okay, so you're able to get valuable insights now from the comfort of your desk, right? Into the world around you with our AI-based analytics solutions. So sometimes that means, hey, where are all my street signs? Where are all my fire hydrants, right? We're doing a lighting study. We don't know what kind of lights we have in our city. But ultimately, you know, our pixels, points, and precision, really, if you add those up, it turns into actionable insights for our customers. And we pride ourselves on tying our projects to the priority business needs or challenges that they're facing, right? So we continue to innovate here at Cyclomedia to allow even more questions to be asked of what we believe is a foundational data set of today's smart city. So back to you, James.
Okay, thank you, Jason. So when the dust settled and the trucks had finished, this was back in 2016 when they initially collected this sign inventory data. It left us with a very significant GIS of sign data, and to the total of 200,000+ signs. And to the right, or excuse me, to the left, there's an example of the detail that I was talking about. So we have certain signs that are, again, complex parking signs. So we want to know more about than just it's a dot on the map and it's a residential parking sign. We need to know the times and days and the zones and the arrows and all that stuff. And that's exactly what they captured for us. And so it gave us a great starting point to where we really didn't have anything to a very, very detailed GIS of the sign. So here's an example of that sign that I was just showing. And you can see all the rather complicated, some would argue overly complicated parking data that was actually extracted from that sign. And what's really great about this is when you get it into GIS, this is one of those stories I love pivoting to, because it's once you get a very detailed GIS of something, now the fun starts basically. And so you're like, well, what can we do with it? Well, naturally, since we're a Department of Transportation, we have a linear reference network that we're required to maintain. And we can do some pretty fun things with that if it's matched up and synced to the sign inventory data. So that was our first plan of action, was to all the dots on the map that you may have seen before, imagine that they're synced to, joined to the centerline roadway network. And once we do that, we can get stuff like this, which is a speed limit, linear representation with speed limits in DC. And typically, a lot of times, this is one of those things that cities and states actually put out for a data collection, a completely unique, just separate data collection. Go collect all the speed limits in our entire area for our inventory. If you start with a sign inventory that's up to date and managed and continually updated, you can simply push a script button that we've actually written a script that we're happy to share with anybody that will join it to the network and create a linear representation of the speed limits in your network. So you can do that. Another thing is using, again, the same sign inventory data, we're able to do that same sort of process by joining parking zones, stitching them together to make linear representations of where you can or cannot park, depending upon the time of day. And so here's kind of the fun thing about this. This app that I'm showing on the screen, we did not make. This is actually a product from our colleagues in the open source world. They're called Shared Streets, and they've created a basically think of it as a GTFS for curbside data, for parking data. And this is basically they were able to ingest our data simply because we adhered to their specification. And we didn't have to lift a finger. We didn't have to make an app at all. And since we were able to fit it into a spec, we drew our data our data design so that it would fit easily within their specification. And so when you think a little bit about that, it's great because you can do things like this and make sharing data easy, make app building easy if that's not your forte. But let me come back to this little bubble diagram, right? So we're talking about all the stakeholders, and I'm showing you all of the cool things that downstream safety is going to be happy, planning is going to be happy, curbside management is going to be happy. Basically, all those bubbles around the sign shop are going to be happy, and the public too. But really, if you think about it, those are really almost downstream stakeholders. They may request changes of the signs, but really, there's kind of a functional difference between all of those folks and the middle bubble. And the reason is that those outer bubbles represent downstream stakeholders. Upstream is the sign shop. In upstream, it's a completely different story. And here's why. Primarily because all of the requests for new changes, new supports, new signs, changes to existing things, are communicated via kind of like plan sets, PDFs, custom form-filled documents that may be emailed or attached to a work order. And really what it's digital, quote unquote, but it's not really actionable, machine-readable data. And it's definitely not connected to the GIS I was just highlighting. So even though we have a cool GIS sitting around, we still have literal mountains of paperwork coming through the offices of the sign shop, simply because it's too complex to really connect to the GIS assets. Too hard to disrupt the current workflows in order to connect to GIS and make things easy. So what do we do about that? They really liked the maps that we showed. We got good feedback from them, but the reality is that they think of the world kind of, how do I execute my work in a paper-based system? I can look at those maps, I can pin them up on the wall, but I can't make that the way that I communicate with my assets. I change my assets. I can't use them in that same way. So they gave us the cool maps, bro, but it's not going to work for us. So this is what we did. Everybody is a part. Everybody kind of interacts with the sign data in their own way. And we have this GIS that's kind of sitting there ready and waiting to be used, but only really IT and certain folks can actually access and use it. And so that's when our beautiful dream of having this great GIS of all the sign data, of all the, where everything is, it's basically sitting there since 2016, not doing anything. And that was a major blow to my personal pride. And we had to go back to the drawing board to figure out how we can bring these folks to connect to the data that we just recently collected. So this is what we did. Okay. Sorry, I couldn't resist. I think we've kind of set ourselves up for failure, because there's no way that our app is as cool and as awesome as Star Wars. But you know what? It just seemed to fit. I saw that animated sign thing, and it just had to happen. So anyway, so what we did was we took a look at both the upstream and the downstream, and we had to consider both while making sure that we respected the data that we'd collected, but also how does that asset get changed out, and making sure that with every change out, there is a corresponding commit to the database to reflect that change occurred. And so it's been really, really hard, and it has taken us probably nearly about 3 years just to get these groups to be closer and closer together. And so anyway, SignWorks is an app that we've made. We're not super high speed and slick like a lot of these presenters, but I think that kind of underscores the utility of both the data, but also being able to leverage a street smart Cyclomedia API to help really bring things together, so that we can kind of fill in our technological skill gaps and do a really effective app that allows our users to change the data, to view the data, to find the data whenever they need to, and it's not going to be a burden to them. They don't have mountains of paperwork. They'll have an app that they can go to commit their work. So anyway, what I'm going to do is highlight a couple of recorded sessions that we had made that just sort of demonstrates how we're interacting with our sign inventory data. So here we go. So it all starts, of course, with the map of the sign support locations. And so that's what we start off with. And so a user can select a sign support location and then have an interactive view of not only where it is on the street, but also have a view of where, what the street level image view of that same asset is. And you'll notice I have a car in the way in this case, and I can't quite see exactly where this thing is placed. Well, I can go to the time travel location, look at last year's recording, where magically, thankfully, a car was not in the way this time. So we can kind of roll back time, look at that same asset location to see what it looked like last year. Additionally, we can directly interact with the Cyclomedia window on the left-hand side. We can click a button, one of the dots on inside of the image, which represent the GIS sign support location for where we have sign data. And after a few minutes, you can zoom in and see on the right-hand side, we have the sign asset data, and on the left-hand side, we have the most recent Cyclomedia image of that data. And you can see that in certain cases, we have a mismatch because we have 4 signs on the left, 3 on the right. So let's go ahead and make the data better. A lot of things may have changed in the last 3 to 4 years. So first and foremost, we have, it looks like, a new parking sign that we need to add. So we can use the tools to search for the right type of sign. We don't have to know and memorize the METCD sign catalog, but we can just start typing what's on that sign and we can find the right one. Select the right arrow, and in certain cases we have the ability to designate certain signs as has specific geographies. But I don't know if you can see from the video here, but there are actually 3 different time and day combos, and we call these time bands within SignWorks, where it's a Monday through Friday morning time, Monday through Friday evening time on the Saturday, and then finally a Saturday only time from 7 to 6:30 p.m. So that's a lot of data, and it's really, I think in most apps that we've seen about sign inventory, they sort of treat this as variable text. It's where every sign is somewhat unique. But we have the ability to kind of capture it all, and it's all in a database now after we make that change. So once we're done, we hit save, and then we also have the ability to, if you'll notice on the right-hand side, we can actually reorder the signs dynamically and interactively on the right-hand side. It gives us a lot of abilities to kind of show the signs in the context that a lay user might understand them. So they see them as stacks of signs, one on top of the next, and that's how we represent them within the app. Additionally, there's certain occasions where we're going to look at the data and notice that there's things that are wrong with it. So in the case that we have here, we have a situation where that one dot that's right here in the middle is there was an ADA curb ramp that was recently installed, and the support has been moved to a different location. Well, using the app, we actually have the ability to move that within the GIS, but rather than using an overhead aerial image, we use the natural way that you would normally do it. We can actually update the GIS to within 10 centimeters accuracy right in the image. And that's what we were just showing you there. So as we click on the location, we have the ability to update it. So you'll see it's an updated location, but you'll see just to the side of it here, we have another example of where here we have a signal that looks like it may be brand new. We don't have that in GIS right now. We can add it into the GIS. And again, we're just using the imagery and the GIS that's embedded within the imagery to help us find that 10 centimeter plus or minus accuracy. So I go to the base of the support, I nail down a point that will eventually become my new point GIS for that specific thing. So if you look in the middle of the map here, that's the new location. Let me just open up the image again just to make sure that it's in the right location, and it is. So I think the last thing that I did here was just make sure I had it as a signal. And there we go. So things that would typically be field-only workflows where you have to have somebody physically drive out to that location, make sure that they have maybe a handheld GPS to really nail down the exact right spot. This was all done COVID-19 era, less than 3 weeks ago. So we were able to be effective digital workers in a DOT and safely implement and upgrade and improve the data that we have in our database without risking any sort of public workers at all. All right, so next steps are to eventually deploy this application to production. So the one that I was demoing right there is our inventory update QC analysis, which is SignWorks inventory. And that's the one that is actively being used for the QC of the data I mentioned before. In addition to that, we have another set of groups that we want to kind of integrate with this app to help make sure that it's available and useful for everyone. And always, since I can't shirk and get rid of my GIS instincts, we've got to make more cool maps for the next conference, because that's what keeps people interested. That's what keeps me going. You know, the better data that we have, the more people that we have touching data as part of their day-to-day asset management activities, the more reliable the data will be, obviously, and then the cooler the maps will be, I believe. So we'll see. So here's some folks that are actually at the forefront of making this app happen. So we have John, who's the developer, and Anji is the developer of the request app, which I was not able to demo today, and Oshin is the one who's kind of the Python scripting whiz in the background. So great team to work with. I wouldn't be here without their hard works. And I think without further ado, I think that concludes my presentation. But again, I want to thank my co-presenter Jason for giving Cyclomedia spin on the project. And you can see it's an integral part of how we intend to manage signs from now into the future. And we couldn't really do it without him. But thank you everybody for the time and the opportunity to present to you today.
Yeah, thank you, James. There are some questions. I really enjoyed the presentation, and the something I was really impressed with was that you know, making the non-sensitive data available to the broader communities, the open source community. If people have data, they're going to do good things with it. So you know, and it's about the non-sensitive data, though, of course, you know, have to be aware of that. So the one of the questions along that line is from Chris R., a surveyor. He said, are faces and license plates blurred out in the imagery, or any that's made more broadly available?
Yes, they are. I'll say that while I was showcasing an app that edits data, which we ultimately make available to the public, we are not currently licensed to share the Cyclomedia data, the interactive version that I was demonstrating to folks. So yeah, I believe maybe Jason can provide some additional information on that.
Yeah, sure. It's a common question that comes up by our customers, and usually we do have customers that want to be able to showcase the imagery in the public domain. And for those customers, if that's ever going to be the case, just from a public safety perspective, number one, they have to remove all measurement tools for hopefully obvious reasons. And we also offer a privacy filter option. And what that does is blur out any license plates or faces that might be. A good question.
Okay, cool. So reminder to folks, if you've just joined us for, you know, sessions to follow, if you haven't yet, download that guide or connect to online to the guide. You'll see it in the chat panel, the link to it, the asset mapping.events guidebook. Do that. Also, if you have questions, put it in the Q&A box. If you have questions about the interface or how to navigate in your Zoom interface, use the chat. So we'll try to keep those separated. Jason and James, we've got another question from John F. He says, cool, the benefit of a GIS adds the human perception. Consider maybe that they have too many signs, which may mean may mean root cause is too complex a parking enforcement code?
I know exactly what he's asking
I
about.
think the signs are getting picked on, James.
Yeah, we call those totem poles. Yeah, so that's one of the things in our database that we have is kind of sign order. And so I think our current record that we have right now is six signs, but we're not done with our QC yet. So that record might be broken, but I 100%, that's one of the things I can't wait to see is where do we have a relationship between high amounts of signs and crash data. That'd be maybe a fascinating follow-on, but once we have the data QC'd, I want to definitely ask that one.
Cool. Another question, James. Are you using Esri roads for your LRS?
We are using Esri roads and highways, yes.
Okay, thank you. Thanks for the question, Brian. A question from Bill E. is, what data collection, this is probably for Jason, what data collection system did Cyclomedia use for this project? Was the appropriate MUTCD sign code derived from the mobile imagery, by automated software, feature recognition, or manual input?
Yeah, another great question here. So number one, we capture using our proprietary vehicles or assets, as we lovingly refer to them. There are 5 cameras on top, and I just share that because there's no parallax, so you don't see any stitching or kind of fade lines or that you might see in other commercially available street level imagery. And then beyond that, moving towards codes, anytime we do feature extraction for a customer like DDOT, it isn't cookie cutter, right? So it's very important to understand what DDOT's needs are versus CDOT versus TDOT versus whatever DOT across the country or public works, right? Because understanding those challenges up front, some of that we absolutely can do with machine learning or our people power on our side with those AI-based techniques. And in other cases, our customers end up filling in those blanks or doing it all on their own. I don't know if you want to add anything, James, to that.
Sure, yeah, I'll only add that, when we requested this data collection, we, in addition to the MUTCD library, we requested, I can't remember how many, but we gave them a collection of our non-standard signs, which was primarily DC's unique and overly complex parking type signs, which we said, get me MUTCD plus this other set that is just specific to DC, and they did that.
Okay, great. A question, somebody had put this in the chat box instead of the Q&A, but try to keep the questions about content in the Q&A, but thanks John C. for this question. What are the sign shop field workers using to record updates around the city? How does that workflow work, James?
Well, right now that's kind of our last task is to make sure that the technology flows into the sign shop. So we've been prototyping, and right up until COVID happened, we were on a weekly schedule to just make sure that once you get this work order in CityWorks, that's our asset management system, it's going to be infused with all the GIS and everything that's going to take you right to the spot and make sure you know exactly what to do. And we're not finished yet with that part. It is not fully built out, but they will be using CityWorks Mobile in the field, but that will have been a work order that's generated from SignWorks. So yeah, I would probably say we're not quite done yet is the short answer, but we're very close. Hopefully once we physically return to the office, we can finish that one.
Okay, and actually I want to follow up sometime in the future and see how you did decide to do it, because I know a jurisdiction that's facing the same task. A question from Kirk H in the Q&A box. what is the underlying data structure for your GIS? Probably hard to thumbnail that very quickly, but give it a shot.
Sure. Yeah. I think maybe what I'll do is after this presentation, I'll share with you a link to our departmental wiki, where we've kind of drawn out the structure of the data, and then also just how the basic process flows for the app work. But it's real simple. You know, the primary point you see on the map is the sign support GIS feature class, and then there are two child tables, one for the signs themselves. The signs are non-spatial table, and then we have related to signs as a child table. Each sign is the time restrictions or time bands. So 2 points, or 1 point and two tables.
Okay. Another question from Jim C. Is this entirely living within the GIS or in tandem with other apps or databases? Any plans to integrate with other asset management systems like Cartograph?
Right. So in addition to our integration that we showed with Cyclomedia, we are able to generate swap out or replacement work orders, where we can generate a work order from SignWorks to CityWorks. That's our asset management platform. But that's going to be the primary asset management system that we interact with. But later on, if we're going to capture all those different bubbles that I was showing multiple times in the presentation, they have their own enterprise app that occasionally interacts with sign data, so we'll probably need to visit them down the road. But the primary one is just the Sign Shop asset management app.
Okay, a question from Paula R. Are there any ADA issues that you have to address follow with placement and markings for the signs?
Oh, that's a good question. Yes, but what we see is that there's a lot of specific signage that has tangential connections to other spatially hard to model sort of data items, and stripings, markings. It's just one of those things that I think that signs is tough. That's really tough. Yeah, I think there's certain types of signs which necessitate a corresponding pavement marking kind of action. And we just have to work with that team to make sure we identify this sign means that we're going to do X, Y, and Z, and then probably kick off child work orders in support of the originating parent work order for a sign asset replacement.
Okay, a couple of questions. Well, as a surveyor, these ones hit home for me because these are the things I would ask. One is from Dan M. What could be expected for vertical accuracy of street furniture? For example, like if you were to do manhole lids, manhole rims with this same process. Is really a question for both James and Jason.
Yeah, Jason, you want to take that one?
Oh yeah, sure, no problem. This is usually a common question, because when you're in, you know, our solution or thinking about our imagery and LiDAR and things that we're collecting, you know, now not only are you in XY space, but you're also in X, Y, and Z, right? So you have that vertical as well. And what we like to say on average is inside 4 inches for positional accuracy, okay? And then, you know, getting down to that, the smaller accuracies in our plane, right? Measuring from pixel to pixel, you can get even tighter than that. But that, on general, is usually how we answer that question. Great question.
Okay, thank you, Jason. And a related question, which is, I'm sure you hear this one a lot. Did Cyclomedia set ground control to get the dimension 10 centimeter accuracy?
I'm honestly not sure on that, and I would have to check with the team in the field that actually did that. But I can get back to answer that question, unless James is aware of the answer.
I don't know. I'm sorry.
Okay, I think, yeah, a lot of us, me included, would like to hear a little bit more about the mobile mapping process side of it. So A follow-up comment from John F., who asked the question earlier. He said, it demonstrates the value of good comprehensive data to improve quality for the target user and public. So, cool.
Thank you.
And we're about to start the next session, but I've got just a quick question for Jason. You know, we hear a lot about automated feature recognition, and it's every week I see another startup saying, yeah, we fully automate it. They don't go into a lot of detail. I mean, but there's limits. I mean, you have to teach it to, or have libraries of, say, the signs to recognize those features. What's the most wild thing that you guys with Cyclomedia have been able to automatically recognize?
That's a tough one. And again, I wish I had somebody else on the call to answer that. But you know, I have been here a few years, and with machine learning and AI, I mean, just as you alluded to, Gavin, it's constantly evolving, right? It's machine learning. It doesn't know it all to begin. And going back to my earlier comments, you know, we had a very specific need here with DDOT, and they knew exactly what they were looking for, right? But we worked with them to figure out, okay, here's your MUT to CD signs. We've got those, but we had to learn about all of these other signs that they needed, right? So every project can be different, Gavin, with the percentages of automated versus, you know, manpower, right? Or semi-automated, for lack of a better term. So hopefully that helps give you some insight to, you know, how we're innovating on our side. But the craziest thing I've seen automated is the certain measurements of ADA compliant ramps. If you think about all the intricacies and the, you know, 14, 15, 16 measurements and features on an ADA, you know, pedestrian ramp, how crazy that gets to be able to have things in the background that are identifying and measuring, you know, slope, the pads, all of that compliance work. It's really, really amazing stuff.
Okay, thank you, Jason. Remind both you and James that there's a couple of unanswered questions that just came in at the last minute in the Q&A box, and gave me an idea of a few things to bring up in the coffee break, the open session at the end of the day. We're going to move over to our next presentation.